Hello students. So this is the question which has appeared in IIT JEE Advanced 2015 and one of the very interesting questions from coordinate geometry. So let's solve this question. Let E1 and E2 be the two ellipses whose centers are at origin. The major axes of E1 and E2 lie along x-axis and y-axis. So from these first two lines, we can easily make out that this E1 and E2 are standard ellipse. One is having axis along x-axis, other is having major axis along y-axis. So we can say ellipse E1 will be having the equation x square upon a square, center at origin, and major axis is along x-axis. So this is x greater than a greater than b, right? And E2 is a vertical ellipse, that is its major axis is along y axis. So here you can say a is less than b, standard thing, right? S is the circle which is having center, you can see at 0 comma 1, and radius is equal to root 2. It is given in the question. Now a line x plus y is equal to 3 it touches the curve S, E1 and E2 at PQR. So this is touching these three curves at PQR, that is common tangent, right? And it is given that PQ is equal to PR is equal to 2 root 2 by 3. It is given, right? And you have to find the eccentricities, basically E1 and E2, and you have to find the relation between E1 and E2. So what is eccentricity E1? So E1 square, you can see for the first ellipse E1, which is horizontal ellipse, a greater than b, what is the eccentricity? 1 minus, you can say, b square by a square. And for the second, you can say this is the vertical, so this is 1 minus b square by, a square by b. You can say a square by b square, because this is a vertical ellipse, okay? A is less than b. So ultimately you have to find these two values here, right? So how will you approach this? How will you get the relation in E1 and E2, A and B? So that is what we have to understand, okay? So let's draw the diagram here. So let's say this is our coordinate axis, right? And this is our horizontal ellipse, that is E1. Here A is greater than B, okay? Now let's say this is the vertical ellipse. This is A is less than B, vertical ellipse, okay? We have written the equations. Now a circle which is having center at 0 comma 1. So let's say this is the center at 0 comma 1, okay? Just drawing the diagram, rough sketch, okay? And a line x plus y is equal to 3. So this is the line x plus y is equal to 3, okay? Is touching these three curves at some points P. Let's say this is point P, this is Q, and this is R, and it is given that PQ is equal to PR, that is this, is equal to this. This is equal to, I can write here, this is PQ is equal to PR is equal to 2 root 2 by 3. And now you have to find the eccentricities of these two pieces, okay? So first thing you can observe here, we are having the distances PQ and PR. So if you have these distances 2 root 2 by 3, this is also 2 root 2 by 3, you can clearly see on this line you have to find 2 points which are at a distance, which are at the same distance from this point P. So if we can find point P, we can easily get the coordinates of Q and R by using parametric coordinates, parametric equation of a straight line. So for that, first you have to find point P. Now how will you find point P? That is the first question. So it is given that this is x square plus y minus 1 square is equal to 2, equation of this circle, and the line is x plus y is equal to 3. Now this line is touching this, that means you can say if you have to find point P, so can we say P is the point of intersection of these two, that is point of tangency, because it is given, definitely this is touching. So if I solve these two equations simultaneously, so if I just put x is equal to 3 minus y in the first, so you will get this is 3 minus y whole square plus y minus 1 square is equal to 2. So that is, you can say 9 plus y square minus 6y, and this is plus y square minus 2y plus 1 is equal to 2. So this is 2y square minus 8y, and then you can say this is 9 plus 1 10, 10 minus 2, this is equal to 8 is equal to 0. So basically this is y square minus 4y plus 4 is equal to 0. So you can clearly see this is y minus 2 square is equal to 0, that is y is equal to 2. So we have got this y is equal to 2. So what will be x? X will be equal to 1. So we have got the point x, this is 1 comma 2. All right. So this is 1 comma 2, right? You can solve this by, you can find this point P by using the foot of perpendicular formula also. There are different ways to find point P, right? So idea is you have to just find the point P. Now how will you get the point Q and R? You can clearly see the slope of this line. Slope of this line m is equal to minus 1, right? This slope is minus 1. That means the angle of this, that is angle with positive x-axis, this is tan theta, that is theta is equal to 135 degree. So for this line, tan theta is equal to minus 1, that is theta is equal to 135. Basically this is 135 angle. This is the angle 135. Now you must be knowing how to write the coordinate of a point on a straight line which is at a distance r from the given point P. So how will you get this point? So you can say point R will be 1 plus 2 root 2 by 3 cos theta, that is 135 degree, comma 2 plus 2 root 2 by 3 sine 135 degree. First understand this. This is I'll just explain this how to write the parametric coordinate. You can say this is x1 plus r cos theta comma y1 plus r sine theta, where theta is the angle with x-axis, positive x-axis, that is corresponding to slope, that is theta. Okay, and what is point P? Point P is given point from which you have to measure the distances. R, what is the R? R is the distance from the given point. And similarly, if you have to write the point Q, you can say this is 1 minus 2 root 2 by 3 cos 135, and this is 2 minus 2 root 2 by 3 sine 135 degree. Okay, so we can just simplify this. Cos 35 is minus 1 by root 2. So this will be 1. If I cancel this, this will become 1 minus 2 by 3, which is equal to 1 by 3, and if I cancel sine 135 is 1 by 2, 1 by root 2, so 1 by root 2 will be cancelled, and this will become 6 plus 2, that is 8 by 3. And similarly, if I check this, cos 135 is now minus 1 by root 2, so it will cancel, and this will be 5 by 3. You can check the calculations. This is, and if I cancel this 1 by root 2, you will have 6 minus 3, 2, that is 4 by 3. So we have got these points, that is point R. Point R is 1 by 3 comma 8 by 3. And similarly, what is this point? This is 5 by 3 comma 4 by 3. Now how will you use these points? Understand this. Okay. So you can see here, for the ellipse E1, consider for ellipse E1, which is x square upon a square plus y square upon b square equal to 1. You can see this point is on E1. Now at this point we know the tangent, that is x plus y is equal to 3, and we know how to write the equation of tangent at a point Q, which is what is point Q? You can see this is 5 by 3 comma 4 by 3. This is 5 by 3 comma 4 by 3. So what is the equation of tangent? We know at a point tangent is t equal to 0. So what is this? This is, you can say, replace x square with xx1, y square with yy1, and constant remains same, right? So this is the equation of tangent at 5 by 3 comma 4 by 3, which is on this ellipse E1. But it is given in the question that the tangent at point Q is x plus y minus 3 is equal to 0. X plus y minus 3 is equal to 0. That means from these two, can we say they should be identical, because at the point they should have the same equation. Tangent has the same equation. So if I compare, what is the condition for two equations to be identical? A1 upon A2 is equal to B1 upon B2 is equal to C1 upon C2. So you can clearly see this is 5 by 3 by A square divide by 1. So I'll just write this is divide by 1. 4 by 3 B square divide by 1 is equal to 1 by 3. So you can just arrange this. You can see this is 5 by 3a square is equal to 1 by 3 and 4 by 3b square is equal to 1 by 3. So now what is a square? This is equal to 5. A square is equal to 5, and what is b square? B square is equal to 4. Okay. Now same thing you can do for the other ellipse also. So for E2, what is the point is x 1 by 3 comma 8 by 3. So this is x square upon a square plus y square upon b square is equal to 1. Okay, and point R, they have got point R, which is 1 by 3 comma 8 by 3. Now what is the equation of tangent? You can see this is again t is equal to 0. So what is t is equal to 0? You can say this is 1 by 3 x by a square plus 8 by 3 b square is equal to 1. Again replace x square with x1, y square with y. Okay, and this tangent is x plus y is equal to 3. Same point, right? The tangent equation at R is again x plus y is equal to 3. So this is x plus y equal to 3. Again, if I compare these two, because these are identical equation, if I compare, this is, you can see 1 by 3 a square is equal to 8 by 3 b square is equal to 1 by 3. So from this you have got what is a square? A square is equal to 1 by 8. You can, a square is equal to 1, and what is b square? B square is equal to, you can see, 8. Okay, so we have got the values a square equal to b square, and you can clearly see this is a, here a is greater than b, and here a, that is 1, a square is 1, so a is less than b. So the starting point which we had, that is a and b are a is greater than b, a less than b, those points are also valid with the values here. Okay, so now what is a square by b square? You can see what is a square by b square? This is equal to 5 by 4, and what is a square by b square from this? This is equal to, a square by b square is 1 by 8. Now you can substitute all the values here. So now we will check this. What is a square by b? What is a square by b square? This is 5 by 4. So this is, what is eccentricity? E1 square, E1 square will be equal to 1 minus 4 by 5, which is 1 by 5. Okay, from this. And what is E2 square? E2 square is equal to 1 minus, you can see, what is a square by b square? This is equal to 1 by 8. Okay, so this is 1 by 8, which is equal to 7 by 8. Okay, and now you can clearly check the options here. What is E1 minus E2 square, and so on. Okay, so this is how you can solve this question. Okay, so now I hope you can easily check the options from A, B, C, and D. Okay, so this is how you can easily approach this question by using the concept of tangent and parametric equation of a line. Okay, that's it. Thank you.